Alright guys, so this is another video, but this time we're looking at the simple harmonic motion graph. So this time around I'm looking at my displacement, my velocity and my acceleration. I've already drawn in the graph shapes, but we're going to explain why we get these through. So this is starting off at a maximum displacement. So if I was coming down to like a pendulum here, I would be starting off from my maximum displacement and letting it swing through and back for one complete oscillation. So remember, one oscillation is the complete there and back of it going through. So we're looking at this down through on this stage. I'm just going to move this up a little bit and I'll come back to those graphs in a second. If we look at the time of zero when it's at this point here, it's at its maximum displacement. I'm saying that this is the positive displacement, which means it's also at maximum acceleration at this point. It also means it's at the minimum velocity. Its velocity is actually equal to zero here. Okay, now the other thing to bear in mind is we know that due to simple harmonic motion, the acceleration is in the opposite direction to the displacement. So my displacement is positive, my acceleration is going to be negative. Okay, as it swings through, we get to t over 2. Okay, at t over 2, we've got maximum velocity, which also means that my displacement at this point is also equal to 0. My acceleration, because it's reached its maximum velocity, is also equal to 0. And then we swing back up to t over 4 to t over 2 up here. Again, this is in the negative direction now, so I also have I've got a maximum displacement, but my maximum displacement is negative. I also have maximum acceleration, and again I have minimum velocity, which is going to equal 0 here. Now in this case, what we can start looking at is we start looking at these graphs and imagining as it swings through. So we've got t over 4, t over 2, 3t over 4, and then t over here. All right. So we've got those different situations to fit our oscillation on. So if we look at our velocity, it's not velocity, our displacement first of all, we started off at a maximum, but we're going down. Okay, so I start to see my gradient as well is going negative at this point. So we swing through until it reaches at 0. Okay, then we swing back around up to a maximum, but in the opposing direction, so it's negative. And then we're going to start going back towards in the positive direction. So I'm going to see my graph start to increase again. So again, we can see it going back like this way. Getting again to that 0 point down here, and again swinging back up to our positive displacement at the top. So it's a little bit like rubbing your stomach and patting your head, trying to do this at the same time. Acceleration is the easiest one to probably do next, because we know with simple harmonic motion they are directly proportional but in the opposite direction. So you can see here we're at a maximum acceleration but in the opposite direction. Okay, so I'm starting off in the negative there, but this time around I'm actually going to be swinging right through, so I'm increasing and increasing. Okay, as I'm getting into more of the positive direction. That doesn't mean I'm increasing the acceleration here. I'm actually going to reach 0 at this point because I'm increasing the speed to its maximum point. Okay, and then continue to swing up to become in terms of maximum acceleration in the positive direction. And again, then I'm going to swing back through. Okay, and I'm going back in towards the negative there, and then coming back round into the negative displacement, back on where it is in the positive, so negative acceleration where it's got the positive displacement. Okay, so if we look at these, where I'm getting a cosine graph for my displacement, I'm getting the complete opposite, so a negative cosine graph. So remember, they are doing the opposite each time. Velocity, okay, we know that we're going to be starting at 0. We've got 0 displacement there, but we're swinging through, but again, we're moving away from the positive towards the negative, so we're going to go down in terms of like our negative direction. So we're going to be swinging away from that positive, going down to reaching its maximum at that point here. Okay, swinging back around, I'm going to go up. Okay, again, going back up to 0, so I'm still in that negative velocity because it's moving away from the maximum displacement at this point. And then this time around we're going to swing back towards the positive direction. Okay, so I now have a positive velocity, again going through, coming to the maximum point down here, and then going all the way back up there. All right, so again we can sort of see that in this way. So what we can see is that relationship between the two. So when my displacements are at negatives, my velocity is at my positives. Okay, so when my displacement is at 0, I should say my velocity is in its maximum. And when my displacement is at maximum, my velocity is at 0. So we actually get a negative sine graph for these. Now, we're not going to talk about the cosine, sine, or negative cosine until we do some of the equations. But we can also describe this in terms of the phase difference between them. So I'm going to do another video about phase difference, okay? But essentially it's how much has been shifted along, all right? So we would also say down here, okay, that this would be pi out of phase, okay? Whereas my sine graph here, okay, it is lagging by pi over 2, or it's leading by 3 pi over 2. Now, if that doesn't make much sense now, watch the little video on phase difference and I'll explain that through there.